Hello, hello, hello. Testing my testing. Hello. Okay. My name is Rahul Rajput and my qualification is MSc and BTech from University Kanpur. So I am starting the chapter of physics, gravitation. Before we start this chapter, we are discussing about the gravitational force. Gravitational force means if two masses are given, let us suppose this mass is the m1 and this mass is the m2. So between these two masses, their force will be acted, which are these force are known as the gravitational force, and this force is attract to each other. If m1 is this and m2 is this, then between these masses the gravitational force will be acted, means that force will be the gravitational force. This force is the attractive nature, means cannot be repulsive nature. Before we are discuss in electrical charge, there are the two types of forces. First one is the attraction force, second one is the repulsion force. For electrostatics, means we get the two charges q1 and q2. If nature of q1 and q2 are opposite, then that forces will be attracted the attractive force. If nature of charges will be same, then that forces between that two point charges forces will be acted is the repulsive forces. But here cannot be is this. They are the two masses. We are discussing about the two masses. First masses is the m1 and second mass is the m2. Let us suppose that is the two masses. This is the m1 and this is the m2. This is the m1 and this is the m2 mass. Then between these two masses their forces will be acted, that is this. Let us suppose this is the a point mass and this is the b point mass. Then this force is the attractive force, means this is the F is the attractive force and F is the attractive force. Between two masses the attractive force will be acted, not a repulsive force. Only attractive force will be acted, which are the force on A due to B and force on B due to A. Or we can say, if first masses let us suppose is the 1 and second mass is the 2. So force on 1 due to 2 is this. Direction of this force will be the A to B, from A to B, and force on 2 due to 1. Then force on 2 due to 1, which is the right to left, or we can say B to A is the force on 2 due to 1, F of 1 to force on 1 due to 2. So there are the two forces. In these questions the forces will be is this, means between that two forces the force will be the always m1 into m2, and force is also is inversely proportional to square of distance. So force is directly proportional to the m1 m2. If two masses m1 and m2 are given, then force is directly proportional to the product of m1 and m2. And if distance between m1 and m2 is small r, let us suppose this distance is the small r. Okay. Now here we are discussing about in magnitude. So in magnitude that forces will be equal. In magnitude that forces will be equal. Force on 1 due to 2, magnitude of force on 1 due to 2 equal to magnitude of force on 2 due to 1, which will be equals to F. Let us suppose this force is equals to F, means we can say force is directly proportional to m1 into m2, means if m1 is 1 kg, m2 is 2 kg. Another condition, m1 is 4 kg and m2 is 10 kg. Then before initial condition 1 m1 m2 2, then force is greater than less than the second condition. If mass will be greater, then force will be greater. If mass will be less, then force will be less. means mass is treated as the product of a mass. M1 and M2 is this. Then force is directly proportional to product of M1 and M2. And force is the inversely proportional to the square of distance between the M1 and M2. So this second condition are known as the inverse square law. This is the important point. Inverse square law. Inverse square law. F is directly proportional to 1 upon r square. Inverse 1 upon r square. This is the inverse square law. According to mathematical, F is directly proportional to 1 upon r square. 1 upon r square means is inverse and square r. Inverse square law. So any quantity is proportional to 1 upon r square, then that condition are the follow the inverse square law. So force is directly proportional to 1 upon r square. Combining this force, equation 1 and equation 2, then force is directly proportional to m1 into m2 divided by r square. So force is directly proportional to m1 m2 divided by r square. If we remove the proportionality, then the constant g will be comes out. So g into m1 into m2 divided by r square. So this force is the gravitational force. This is the known as the gravitational force. This is force is the known as the gravitational force. This is the known as the gravitational force. And this is the masses. Masses will be point masses, and r is the distance between masses, and g is the gravitational constant. This is the known as the gravitational constant. This is the known as the gravitational constant. The value of g, which will be equals to, the value of g always 6.67 into 10 raised to minus 11. Unit will be the Newton meter square divided by kg square. So the value of g will be fixed. If medium is changes, then value of a g will be fixed. If distance between that two point mass will be a large distance, also the value of g will be fixed. For each condition, the value of g will be fixed in whole universe. So g equal to 6.67 in 10 raised to minus 11 Newton meter square divided by kg square. Also, we have to find the dimension of a g. Unit of g will be Newton meter square upon kg square, means g equals to f into r square divided by m1 into m2, which will be equals to the unit of f will be the Newton. This is the force. R is the distance, this is the meter square, divided by m is the mass, so kg into kg, which will be equals to kg square. So unit of g which will be equals to is this. So unit of g which will be equals to Newton meter square divided by kg square. And third condition is the dimension of g. So dimension of g is this. So dimension of a g equals to dimension of a force into dimension of r square divided by dimension of m1 into m2. Dimension of m1 into m2. So dimension of a force which will be equals to ml t raised to minus 2 into l square divided by m into m, which will be equals to m square. Force F equal to m into a. So dimension of a m equal to m, dimension of a equal to LT raised to minus 2, and dimension of a R square which will L square divided by dimension of M into M equal to M square. So this is the M raised to 1, this is the M raised to 2, one power will be cancelled out, implies that the final dimension which will be equals to M raised to minus 1, L raised to 2 and T raised to L raised to 3, because this is the L raised to 1, so L raised to 3 and T raised to minus 2. So dimension of a G which will be equals to M raised to minus 1, L raised to 3 into T raised to minus 2. So this is the dimension of universal constant which will be equals to M raised to minus 1, L raised to 3 into T raised to minus 2. So also we want to discuss about the gravitational force in vector form. This is the gravitational force in magnitude form. So also we want to discuss about the gravitational force in vector form. Gravitational force, या न्यूटन्स लॉ ऑफ ग्रेविटेशनल इन वेक्टर फॉर्म, या न्यूटन्स लॉ ऑफ ग्रेविटेशन इन वेक्टर फॉर्म. Newton's law of gravitation in vector form means gravitational force in vector form. Newton's law of gravitation in vector form. We know that F equals to G m1 m2 by r square. This is the gravitational force between two point masses, which is the m1 m2, and distance between that 2 point masses equals to small r. So also we want to discuss the gravitational force in vector form. Let us suppose 2 point masses, this is the m1, also this is the m2, and line joining from 1 to 2, this is the 1 and this is the 2, or this is the A, also this is the B. This is the A mass and this is the B mass. The gravitational force will be this condition, because this force will be in attractive nature. This force will be in attractive nature means force on 1 due to 2 is this direction, and force on 2 due to 1 is this direction. Means force on 1 due to 2, 1 to 2, and force on 2 due to 1, which will be the left hand side. Direction is important because for vector form we have to need the two things. First one is the magnitude and second one is the direction. Means vector also can be written as magnitude times direction, not a into dot or cross, magnitude times direction. Direction is the vector quantity and magnitude is the scalar quantity. So magnitude times direction is the also vector quantity, so this will be equals to vector. Between magnitude and direction cannot be applied dot or cross, because dot product or cross product always apply between the two vectors. Let us suppose first one is the A vector, second one is the B vector. So also we remember that A dot B equal to mod A mod B cos theta, A cross B equal to mod A mod B sin theta into n cap. So dot and cross will be always applicable between two vectors. First one is the A vector, second one is the B vector. Because magnitude is the scalar and direction is the vector, so cannot be applied dot or cross, always apply times. So here in vector form we want to find out the f12 and f21. We know that f12 force on 1 due to 2, force on 1 due to 2, because between two masses the force will be a gravitational force will be always attractive force. So force on 1 due to 2 is this, and force on 2 due to 1 is this. This vector cannot be equal because magnitude same but direction cannot be same, direction will be opposite. Yes, this can be written as equal to minus times of, because magnitude same and direction will be opposite exactly. If we taking the mod, then mod of f of a 1 due to 2, which will be equals to f of a 2 due to 1. Let us suppose this force equals to F. So we want to also discuss force on 1 due to 2, which will be equals to this will vector is always written as magnitude times direction. Vector is always written as magnitude times direction. The magnitude which will be equals to is this. Magnitude equals to is this. So magnitude equals to G m1 m2 divided by r square. This is the magnitude, but we are also need the direction, or we can say written as this point, f12 magnitude and times direction. This is the direction, means direction of f of a 1 2, magnitude is this, G m1 m2 divided by r square and time direction. This is the important point. Direction will be what is this. This is the r. R is the distance between that two point masses. Let us suppose position of a point. Let us suppose position of a point, position vector of a point which will be equals to r1, and position of vector b point which will be equals to r2. This is the position vector. Position vector means with respect to origin. This is the value of r1 vector, and this is the value of r2 vector. This is the r1 vector and this is the r2 vector. For any point, if we discussing about the position vector, then that point with respect to origin is the fixed point. So we can say this is the r1 vector, this is the r2 vector. But we have to need the direction of f of 1 2. Direction of f of 1 2, which will be from A to B. If we require the direction of any vector, then we can take unit vector of that vector. If any vector A is given, if we want to find out the direction of A vector, which will be equals to A cap, means unit vector of A. If A is this given, let us suppose A equals to I cap plus j cap, then direction of A vector, direction of A vector, which will be A cap. This is the representation of any unit vector A cap, which will be equal to vector A cap equal to A vector divided by mod of A. A cap equals to A vector divided by mod of A. This is the formula. So we can say A vector is this. A vector equals to I cap plus j cap divide by mod of a means root of 1 square plus 1 square. Coefficient of I square, coefficient of square of I plus coefficient of square of j. So 1 square plus 1 square, that number equals to 2. So direction of a vector which will be equals to j, imply that we can say if we need the direction of any vector, then we can take the unit vector of that vector. Unit vector of that vector. Example is this. So we want to direction of a f of a 1 2. So direction of a f of a 1 2 from a to b. Direction of a f of a 1 2 which will be equals to a to b. Direction of a f of a 1 2 which will be equals to a to b. So direction of a f of a 1 to a to b, or we can say just a b vector, a b vector, a b vector. So direction of AB vector, direction of AB vector which will be equals to AB vector cap, AB vector cap. Okay, what is the AB vector? So AB vector we know that equals to OB vector minus OA vector, OB vector. OB vector is this is the R2 vector, and OA vector is this is the R1 vector. OB vector means the position vector of a B point, OA vector means the position vector of a point. So position vector of any vector, we are taking reference point will be the origin. So this is the R1 vector, this is the R2 vector, this is the given point R1 R2, implies that this is the R2 vector minus R1 vector. So this is the AB vector, AB vector. R1 R2 will be given. So direction of a AB vector which will be equals to AB cap equals to R2 vector minus R1 vector, AB cap equals to that vector divided by mod of that vector, mod of that vector, mod of R2 vector minus R1 vector mod. So direction of a AB is this. We write that point direction of a AB. Direction of a AB means AB cap. AB cap. BA cap is not. BA cap is the B to A direction. AB vector. The direction of the force f of 1 2 is applied from A to B, not B to A. This is the from A to B. So AB cap, not BA cap. Implies that AB cap which will be equals to R2 vector minus R1 vector divided by mod of R2 vector minus R1 vector. So force on 1 due to 2 in vector form equals to G m1 m2 divided by R square, divided by R square means R2 vector minus R1 vector divided by R. R is the distance between A to B, R the distance between A to B. R we can say R equals to means AB vector का magnitude equals to AB vector magnitude. AB is this. So magnitude of that number equals to R2 vector minus R1 vector. R equals to AB vector का magnitude equals to we can say BA vector magnitude. R equals to R1 minus R2 vector magnitude. This is the value of R. But at this time we have to record the value of R. R equals to this number. So R can be written as that number, mod of R2 vector minus R1 vector. So this is the AB vector mod. The distance will be equal. From figure the distance will be equal. AB vector mod which will be equal to R. Then AB vector equals to that, then mod of a AB which will be equal to mod of a R2 minus R1. So write down this point. So that point which will be equals to mod of R2 vector minus R1 vector divided by mod of R2 minus R1 vector k squaring. So this is the force on 1 due to 2. Also we can write is this point. If we want to write is this point, or we can say that number equals to G M1 M2 divided by G M1 M2 divided by mod of a R2 minus R1 squaring into R2 minus R1 का कैप, because unit vector is this is the unit vector. Also we can say this value which will be equal to G M1 M2 divided by R2 minus R1 vector का mod is cube is R2 vector minus R1 vector. So force on 1 due to 2 is this. F of a 1 2 equal to minus f of a 2 1, because magnitude must be equal but direction will be opposite, or we can say f of a 2 1 equal to minus times of a f of a 1 2. So f of a 2 1 equal to minus times of that number. So this is the R1 minus R2. Only differences will be R1 minus R2. So f of a 2 1 which will be equals to minus f of 1 2. So only minus negative R1 vector minus R2 vector. This sign will be affected. Also you can say the value of mod of R2 vector minus R1 vector equals to mod of R1 vector minus R2 vector. There is the no change. This value must be equal because negative will be common. So negative minus R1 plus R2, but mod of a minus 1, mod of a R1 minus R2. So mod of a minus 1 equal to plus 1. So you can write mod of a R2 minus R1 equal to mod of a R1 minus R2. So this will be the Newton's law of gravitation in vector form. Force on 1 due to 2 which will be equals to is this point. Also we are discussing about some questions on gravitational force. We are taking some numericals on gravitational force. The gravitational force first example is this. Let three masses which are given are kept in equilateral triangle. This is the, let us suppose, A point, B point and C point. First mass is kept on M and second mass is kept on B and third mass is kept on C. And distance between that masses which will be equals to A, because we are also tell you this figure is a equilateral triangle. We have to need the gravitational force on A. Net gravitational force on A. Net gravitational force on A in magnitude form. in magnitude form. Also you can find out the direction. Direction of net gravitational force on A. We have 3-point masses. This is the M, M and M. This figure is a equilateral triangle, and distance between that 2-point masses, which will be A and A. We have to need the net force on A due to remaining 2 charges. So as shown in figure, we are draw the net force on A point mass. So we know that the gravitational force always attractive in nature, and direction of gravitational force will be the line joining first mass to second mass, or we can say line joining from M1 to M2 or M2 to M1, because this is the line, so cannot be direction of any line, or we can say the force will be acted along line joining that 2 masses, or we can say that 2 center of masses M and M. We have to need the net force on A due to remaining these 2 masses. Another mass is kept on B and C. So we want to the force F A and B, then force on A due to B. This force is always attractive in nature. So force on 1, if this is the 1 and this is the 2 and this is the 3, force on 1 due to 2 is this, because this is the attractive in nature. So force on A due to C, also this is the attractive nature, then force on 1 due to 3 is this. So this configuration is kept. BC line will be the horizontal, or we can say this is the x-axis and this is the y-axis. Angle between that 2 axes which will equal to 90 degree. So BC is parallel to x-axis. So force on 1 due to 2 and force on 1 due to 3 is this. Because we know that this triangle is an equilateral triangle, so this is the 60 degree, also this is the 60 and this is the 60 degree. So net force on A point due to remaining these 2 masses. So we want to find out the net force. Net force on A. Net force on A, which will be equals to in vector form. Firstly, we want to discuss in vector form. So f of 1 2 vector or plus f of 1 3 vector. We want to discuss f of a 1 2 vector plus f of a 1 3 vector implies that f of a 1 2 vector plus f of a 1 3 vector. So if we want to find the magnitude, for magnitude f of a f net vector in magnitude equals to, if 2 vector are given, let us suppose this is the A vector and this is the B vector, angle between that 2 vectors equals to this. So resultant or magnitude of this vector, which will be equals to A square plus B square plus twice AB cos of a theta. So resultant of these 2 vectors, which will be equals to root of f of 1 2 square. Also we want to find out the f of a 1 2. F of a 1 2. F of 1 2 in magnitude equal to G m into m square divided by G m1 m2 divided by r square. This is the A, distance between A and B, which will be equals to A, and also this is the force f of a 1 2 in magnitude form. So f and f, if this number equals to f, Let us suppose this number equal to f, then f square plus f square plus twice f into cos of angle between f of a 1 2 and f of 1 3, which will be equals to 60 degree, cos of a 60. The angle between any two vectors is always is this situation. If this vector is the A and this vector is the B, so angle between any two vectors is always take the smallest angle, and that two vectors are kept at a point of the tail of A and tail of a B. So this is the two angle. Let us suppose this is the alpha and this is the beta, but we have to need the smallest angle, and A and B will be the tail at this point. So smallest angle is the alpha. So angle between A and B, which will be equals to alpha. Also, if is the A vector and if is the B vector, if this angle is the theta, so angle between A and B is not equal to theta, because this is the A vector tail and this is the head of B vector. No, we are trying to find out the either tail at this point or head at this point, or head at this point, then angle, smallest angle, which is angle between A and B. So we are forward at this vector, so this is the B vector, and this is the this is the correct angle. So this is the theta, or this is the pi minus theta. So this angle is the correct. This is the not equal to theta, because this is the tail of A vector and this is the head of B vector. So this angle is the correct angle. Solving that 2 point f square cos 60. Cos 60 equals to 1 by 2. 2 and 1 by 2 will be cancelled out. So this number equals to root 3 into f, which will be equals to root 3 into f. F equals to g m square divided by a square. So this number equals to net force vector at this point A, magnitude. So magnitude of that two numbers, two आपका mass, that this configuration at a point which will be equals to is this. Also we want to find out the direction of what will be the direction according to this figure. So if the magnitude of f12 equal to f13, so direction will be always the bisector of that 2 points. Always remember that. If we want to the direction, so for direction formula, if this vector is the A vector and this vector is the B vector, so this is the angle theta and this is the angle alpha. Tan alpha equals to so that number equals to what will be happen, B into sin theta divided by A plus B into cos of theta. I think is this. So direction of that two vectors which will be equals to this. Let us suppose this is the A vector and this is the B vector. Try to parallelogram. Parallelogram is this. This is the resultant angle theta and this is the alpha. This is the B vector. So this is the B vector and this is the angle theta. This is the B into cos of a theta and B into sine of a theta. So this is the base and this is the perpendicular, or this angle is the alpha. So B sin theta divided by A plus B into cos of a theta. Okay? But here B into that number we are trying to find out is this point. If we take A vector is this and B vector f of a 1 2, B vector आपका, if A vector is the f of 1 2 and B vector is the f of 1 3, so B sin theta divided by that number, B is f, because we know that magnitude of that number is equals to same, sin of angle between A and B 60 degree divided by f plus f into cos of 60 degree, which will be equals to, the value of f will be cancelled out, sin 60 equals to root 3 by 2 divided by 1 plus cos 60 equal to 1 by 2, the 1 by 2 plus 1 equals to 3 by 2, 1 by 2 plus 1 equal to 3 by 2, this number equals to this, root 3 upon 3 equals to 1 upon root of 3, so tan alpha equals to 1 upon root 3, then alpha equal to 30 degree, implies that this angle equals to 30 degree. If this angle is 30 degree, total is 60, then this angle is 30 degree. So we can say direction of a f net which is vertically downward, because this is the x-axis, this is the y-axis, this is the vertically downward. Vertically downward. Also we can write the net force in vector form. Net force in vector form. What is the net force in vector form? Net force at a point in vector form, which will be equals to, net force is vertically downward, this is the y-axis, plus j cap direction along x-axis, plus I cap along minus y-axis, because this is the direction is the minus y-axis, so minus j cap. So f net a vector equals to, this is the magnitude times direction is the minus j, so net value write root 3 into g m square divided by a square times of minus j cap. So this vector in vector form, magnitude form, and direction will be the angle from f12, which will be equal to 30 degree. Okay. Also we are discussing another questions. If 4 masses are given which are kept on square, the side will be a, and all masses which will be equals to m. Okay, try to this. Also we are discussed for the another questions. Let us suppose the equilateral triangle are given. The equilateral triangle are given. The masses are given on vertex small m, and small m. This triangle is a equilateral triangle. We have to find the centroid for this triangle. We know that for equilateral triangle, the in-center, circumcenter, centroid, orthocenter, that must be are identical point. Implies that we can say we have to need the, if a fourth mass is kept on the centroid, then we are trying to find out the net force, gravitational force on centroid, or we can say this is the, let us suppose this point is the D point. So we have to need the find out the net force on O point. Let us suppose this is the O point. Let us suppose this is the O point. Net force on O point. Also find the direction. Also find the direction and also find in vector form. Net force in vector form. And this force is the gravitational force. This force is the gravitational force. So we are discussing one by one problem. The force between AO. The line joining is this point. Line joining is this point. So force will be acted along is this. So let us suppose this force is the, let us suppose this force is the F1, 2, 3 and 4. F1, 4. Yeah, F4, 1. And also second mass is this given. This is the attractive nature. Force on 4 due to 2. And this is the force on 3 due to 4. Sorry, force on 4 due to 3. So we are trying to find out the net force. Force on 1 due to 2, net force on O point. Net force on O point, which will be equals to force on 4 due to 1 in vector plus force on 4 due to 2 in vector plus force on 4 due to 3 in vector. F of 1, 4, 1, 4, 2 and 4, 3. We have to find the net force on 4th point or O point. On O point. So we are trying to find out the magnitude. What will be the magnitude? We know that this point is the centroid. So for centroid, this is the required distance. AO is the required distance. Also we know that this is the centroid. So this is the centroid. So according to centroid, OA equals to OB equals to OC. This is the condition of centroid. Let us suppose this distance equals to smaller. So this will be, this value equals to small a. Also this is the small a. We know that for an equilateral triangle, if this side will be equal, for any triangle, if this side will be equal, then draw the perpendicular from this point on the front line. So this line will be bisected, means this distance is the half of that distance, a by 2, a by 2. This is the a, this is the a by 2. This angle equals to 90 degree. So this angle equals to 90 degree. A by 2, and we have to require this distance by Pythagoras theorem, because this triangle is the right angle triangle. So due to right angle triangle, this value equals to a square minus that hypotenuse square minus base square, which will be equal to perpendicular, equals to a square divided by 4, and that number equals to root 3a divided by 2. That value which will be equals to, if this point is the D point, this is the AD, this is the AD. Also we know that for a centroid, so total, if this distance is the 10 meter, so this distance is the 2 by 3rd of 10 meter. This is the 2 by 3rd and this is the 1/3. Okay, so vertex and centroid, this is the 2/3, this is the 1/3 of total distance. If A is this and this is the a by 3, we have to need the value of R, which will be equals to 2/3. 2 divided by 3 of distance 2 divided by 3 of net distance. If net distance is the AD, so that number equals to root 3 into A by 2. Root 3 divided by 3, so root 3 whole squaring, 1 root 3 will be cancelled out, then A divided by root of 3. So this R equals to A divided by root of 3. This distance equal to A divided by root of 3. This distance equal to A divided by root of 3. So that distance equals to A divided by root of 3. Okay. Also we find the force. Means force will be equal, because m masses will be equal and distances will be equal, imply that force will be equal. So we can say force on O point. If this is the O point, then force F, that will be equal force. This is the F force and also this is the F force. Okay, we are trying to the net force on O point. Net force on O point, F, and this angle equals to 120 degree. We know that before. This is the 120 degree, this is the 120 degree, because this angle will be equal angle. If angle between that two lines is the, or we can say angle between any two vectors must be equal, then theta plus theta plus theta equal to 360. Then theta equal to 360 divided by 3 equal to 120 degree. So that value which will be equal to 120 degree. 120 degree. This angle is the 120 degree. This angle is the 120 degree. Implies that if we want to find out that angle, that resultant, only F1, 2, 3. If we only concentrated that two force, 1 and 2 and 3. So resultant of this force which will be equal to resultant F2, 3 resultant, which will equal to root of A squaring, F squaring plus B squaring plus 2F into F into cos 120. Cos 120 equal to minus 1 by 2. Minus 1 by 2. Minus F square plus F square. 1 F square cancel. The root of F square equal to F. Means resultant of 2F which will be equals to only F. And magnitude which will be equals to F. So this is the F and this is the F, equal and opposite direction. So net force at this point which will be equals to 0. So net force at this point which will be equal to 0 in magnitude form. Okay, and in vector form, direction can be any direction. The point any point vector, the direction will be any direction. Any direction will be taken for point vector, for zero vector. So this is the zero vector. Okay, so this is the your questions. 3-point mass and force is kept on the centroid. Then we have to need the net force on O point. Okay, thank you.